So as we're moving on through some CodingBat problems, we've encountered the section called array3, and this is just one problem from array3. And of course, array3 is one step ahead, or actually two steps ahead from array1 and one step ahead from array2. And so the difficulty sort of increases gradually as we move through these sections. And so this is array3, maybe a little more complex logic. And maybe more or less it always has two loops instead of one. I think with array 1 we had no loops, with array 2 we had one loop, and then with array 3 we're having two. And so this one's called countClumps, and we want to say that a clump is in an array, and so clump is this classification. So we want to say that a clump, this pattern, is in an array. It is a series of two or more adjacent elements of the same value, and we want to return the number of clumps in the given array. And so moving to IntelliJ here, I said, okay, well, if I thought a clump to be a repetition of a number, so if I had an array here called nums, and that was essentially equal to, let's say, 4, 3, 3, and 2, then I would assume that a clump is a repetition of a number. Okay. And for some reason, I specifically thought that the repetition must be 2. So if we had like a 3, 3 next to each other like we do here, then that would classify as a clump. And so what I said was, okay, well, I'm gonna traverse the array. I'm gonna iterate through the length of the array such that I is less than nums.length, because our index count actually starts from 0. And I would say, okay, well, if nums of I plus 1 is equal to nums of I, then what I'll do is I'll increment count by 1, and I actually don't have to put my braces around the if statement, because it's just one statement. We can do that when we're just having one statement within an if statement, but we can, if we want to structure our program, we can if we want to shortly. And so I bring in this int count variable, which actually keeps track of how many clumps I have in the array. And I would expect to actually, so when I return, or actually when I print out the value of count, I would expect to have, not only would I expect to have, 1, because this condition is satisfied here in this particular array, and I would increment count by 1 because there's one such pattern which actually matches that classification of being a clump. But I would expect that, but before that, I would expect an array index out of bounds error. And I would expect that because I'm actually checking the next element in the array, because I'm doing nums of I plus 1. So nums of I being any given number, and the nums of I plus 1 being the number after that. So I'm actually checking the next element. Now, if I were to be at the end of the array, like I would at the number 2, at the third element, or at the third index, which is the fourth element, I would eventually do nums of I plus 1 and then walk off the edge of the array, and then, of course, encounter an index out of bounds error. So I would have to mitigate that in some sense by doing nums.length minus 1. And so if nums of I plus 1 is equal to nums of I, increment count by 1, and then, of course, return count. And so at the end of this process, I would assume that I would have 1, which works, because I have one such clump. And of course, if I had another clump, which is a repetition of a number twice, I would have 2, and that would also be another clump. But the problem is not in finding these repetitions of 2. The problem much rather is in if we had, let's say, a repetition of, so if I had this particular example here, it seems like I would get 3, and I would get 3 because I have one clump here, which is a repetition of 2, and then I have one clump here, which is a repetition of 2, and then we start off from here, and then we count this as well. So wherever any given element has an element which is equal to it, subsequently right after that element, we increment count by 1, and then, but this is not what we want to do. And essentially, what we would want is we would want to return 2 for our total clump count. Because if you actually go back and analyze the question, clump is just saying if there are 2 or more. So this is for 2. So this is for 2, and now we want to, even if, so if there are 4 5s, that counts as one clump. So here, if we had 1 1 1 1, this is not, you know, 2 clumps, right? This is actually just one clump, because one is a it's constantly repeating, and it's just one clump. So that's so this simplistic version is not really doing the question justice. And so what we do is, all right, so we need to, so let's scratch this, right? And let's keep the for loop. Actually, let's just start all over, right? So we have to have an int count variable, right? And we'll have int I is equal to 0, I must be less than nums.length, and we'll increment count by 1 each time. And if at all nums of I plus 1 is equal to nums of I, and of course we want to mitigate the fact that we could walk off the edge of the array by setting it off by -1. If nums of I plus 1 is equal to nums of I, then what do we want to do? Well, think about it, right? So if nums of I equals to nums of I, if nums of I plus 1 equals to nums of I, then that qualifies as a clump. Okay, so what I'm going to do is I'm going to increment count by 1, because that qualifies as a clump. And let's say I had some arbitrary numbers here. So if nums of I, which is 1 in this case, let me zoom in here. If nums of I is equal to, if nums of I plus 1, which is the next element right after the first, if it's equal to the last element, then we essentially want to increment, we want to increment all the way until that stops being the case. So in some sense, we want to start from where that pattern begins and then stop at where that pattern ends, and that would count as one clump. So you get what I'm saying? So here, if we had these numbers here, like 5 and 2, so we'd start where that pattern begins, and we'll stop where that number ends and count this as one clump. So if that pattern begins anywhere, I count it as a clump, and then I'm going to increment, I'm going to zip through all the way until that stops being the case, right? And so that was my idea, sort of. So what I did was, okay, I'm going to have I'm going to have something called the current element, and I'm going to set that equal to 0. And essentially, the current element will store what nums of I has that pattern. So here, current element will equal nums of I, okay? And so I increment count by 1 just to note the fact that I do in fact have a clump. And whatever that clump is, I'm going to store it in current element. And I'm going to have a do while loop, right? I'm going to have a do while loop here. And what do I want to do? I want to increment count by 1 while nums of I equals the current element. So essentially what I'm doing is I'm incrementing all the way down through the array while nums of I is still that same current element. So here I start at nums of I, and then I check, does nums of I plus 1 equal nums of I? If it does, I want to keep incrementing nums of I until nums of I equals this element. And so here it stops equaling this element, and that counts as one clump, right? And that works. And so that works. And you'll see that if we actually print out system.out.println, we print out count, and let's actually just take a simple example here. Let's say we had 1, 2, 2, 3, 4, let's say, and we run this. We only get one clump because there is one clump. But if we do, so here, if we do 4, 4, 4, 2, 3, oh, we should expect 2 clumps, which is what we get. And so this works. But I want to take a simplistic example. Suppose we had 2 and 2 and 3 and 3. Well, what do you think that would return? It should return 2, but it doesn't. It only returns 1. And it's interesting why this is. It's very interesting why this is the case. And so the idea here is that if we actually, well, okay, first let me take one example. So there's this one thing that doesn't work, right? So let's take this test case and say that this doesn't work, okay? So this doesn't work. And then there's something else which doesn't work, and I want to show you what else doesn't work. So this doesn't work either. If I do 1, 1, 1, 1, this also doesn't work. And so I'm gonna have this on the side as well. This doesn't work as well. And so when we do this, we should expect one clump, right? But it in fact doesn't work. It gives us an array index out of bounds error. So first let's actually target this particular problem, and then we'll target this problem, which should give us 2 clumps, but it doesn't. So I'm gonna write doesn't work here either. And so, so this doesn't work, which we have now, this test case. This doesn't work because, well, think about it. We're at nums of I, right? And so we check the next element and we say, does that element equal what nums of I was? Does nums of I plus 1 equal nums of I? And it does. And so we start incrementing, and we come into this, we increment count by 1. We say, okay, clump exists. We store 1 in current element. And then we go in a do while loop, and the do while essentially says, okay, keep incrementing until nums of I, well, keep incrementing while nums of I equals the current element. And of course, we keep doing that. We say, okay, nums of I is still the current element, nums of I is still the current element, nums of I is still the current element, and we keep incrementing, and eventually we walk off the edge of the array because it never stops being the current element. And so that's a problem. It never stops being the current element. So that is an issue, right? Because when I is equal to nums.length, in other words, when I is the last index in the array, we still keep incrementing. So we want to offset that. We want to say, okay, keep doing the incrementing thing, that's great. But if at all, I is equal to nums.length minus 1, then just break, right? Because we already incremented count. And so we've already counted the fact that a number is repeating. And so we already counted the clump. But if it takes you all the way to the edge of the array, then just break out. And so now it'll actually give us 1 for this particular case. Okay. And so we've addressed this, and now we can say, okay, this works. But now we want to address this, which doesn't work. And actually, I'll pull this up again. I'll put this as the array elements and actually tell you why this may be the case. So we've pulled it here and we've run the program. It only gives us 1 clump when in fact there are 2 clumps. And so what's the deal, right? So the deal is essentially that, well, I'll show you the deal. And in fact, I think I'll show you the deal in Python Tutor, which is a great code visualizer. And I think that would do justice here. So let's actually go to sharing a new screen. Let's go to CodingBat, and let's go to Python Tutor. And this is an absolutely exceptional software. You can put your code in, you can press visualize execution, and it'll actually show you how the code is executing as you walk, or as the computer walks through these lines. And so we'll click next. And so we have, okay, so it's actually not supposed to return 1, so just ignore that. But actually, does that work? Is that fine? So it goes int, and then we have an array, of course, and then we have these many elements. And so as we execute, you can see that we have nums, and it references an array, and we keep moving forward. Int count is equal to 0. The current element is equal to 0, obviously, because we've not sensed any clumps yet, and there's nothing as the current element because, of course, we haven't actually started iterating through the array. And so on our first iteration, when nums of I is equal to 0, or rather when I is equal to 0, the index, the iteration, the variable, we come into the if statement here, and we say, okay, if nums of I plus 1 is equal to nums of I, if nums of I plus 1 is equal to nums of I, then store that in current element. And so now the current element will be 2 because it satisfies that particular classification. And then of course we increment count by 1, and we say, okay, such a pattern exists. And then we put it in a do while, and we keep incrementing until nums of I is the current element, because nums of I too is going to represent the next element in the array. And so we keep doing what is in the do while, which is of course incrementing I by 1 until it stops being the case. And so we keep doing it, we keep doing it, we keep doing it, and we actually see that at nums of I is equal to 2, nums of I stops being the current element, and then of course we jump out. We're at the beginning of the for loop now, and well, we move on, and so we're at 2, and so just I want to show you, this is a pivotal moment. We're at 2, right? Because the pattern stops. Nums of I stops being the current element as we break out of the for loop. And we're at 2 here, and so we would expect, okay, start the algorithm back up from nums of I equals 2, or I is equal to 2. In other words, start the algorithm back up at the third element in the array at the second index. And so we want to start checking from nums of I is equal to 2. We want to start checking at 3, and we want to check whether or not, here we would want to check if nums of I plus 1 is equal to nums of I. In other words, we want to check if the next element is equal to the previous, which is in fact the current element that we're on. But you'll see here that when nums of I is equal to 2 and we want to start the algorithm back up again, we actually jump back to the for loop and we increment I by 1, which we get 3. And then we're actually checking the next. And the next is then essentially subject to this logic, when in fact we want this particular element to be subject to this logic, right? So in this case here, we're actually not checking this element at all. We're not seeing if the next element in the array is in fact the equal to the previous, which is in fact the current, because I gets incremented by 1 as soon as we jump up to the for loop. And so that never gets registered. This clump never gets registered. And so what we do here is we say, okay, don't start from, think about it, right? So I'm going to actually pull this up here. We don't want to start from the next element. When we have this pattern, when we break from here, we don't want to start from the next element. We want to start from here, so that this I, when I is incremented in the for loop, we actually begin from here. So we want to stop right before the pattern breaks. And so what we do here is we can say I minus minus, so that when it comes back up here, it can actually offset that additional increment for I. And so when we visualize the execution now, we actually get the amount of clumps that we wanted, which is 2. So, I mean, that's really how to sort of mitigate that particular, and I think if we took this and we pasted it into CodingBat, I think we will, it'll run properly, right? And then of course we want to return, I think we also took these numbers with us. So let's just go ahead and type it in again. So we had an int count variable, which is equal to 0, and then we had a for loop, int I is equal to 0, I is less than nums.length, right? Increment count by 1. And then if nums of I plus 1 is equal to nums of I, then we can actually store whatever that element is, which classifies for that pattern, in something called the current element equals nums of I. And we'll actually increment count by 1 as well to say that the pattern exists. And we'll enter a do while, and we'll keep incrementing by 1 while nums of I equals the current element. Okay, and of course we want to take into effect if we have a repetitive pattern where we could walk off the edge of the array, and so we say if nums.length is essentially well, if the index that we're on is equal to nums.length minus 1, then we want to break. Otherwise, I mean, this is fine, incrementing is fine. And of course, just to ensure that we start where just to ensure that we start right before the pattern breaks, we'll do I negative negative or I minus minus, and we'll just return the count. And of course, we have to mitigate the for loop, and we'll get all greens.